Hello everyone, welcome back to the session of AIML. It's gonna be a year-long end-to-end session. So yeah, welcome you all for another session on this AIML one-year program. So today we're gonna see data pre-processing, a foundation for success. So this is what the topic that we're gonna learn today. So before going for this session, as we are always mentioning, like please go through all the videos that we have done till date, so that you guys can have a better grip of concept that we what we're gonna learn today. Yeah, so guys, hope you guys are enjoying with us. So we are enjoying a lot. And yeah, let's tightly dive into the today's session. So today what we're gonna do means we're gonna explore data pre-processing process that is available in one of the process of data science. So data pre-processing is a crucial step in data science project. It ensures the data is clean, consistent, and ready to be used by any model like MLA, CV, and then LLM model. Without effective pre-processing, the accuracy and reliability of your model can be significantly comprehensive. So, guys, one thing, as we are mentioning, right, the data collection is important, and we need to collect the primary data. And whenever we collect the secondary data, we need to have some kind of ethics to follow, like those things we are seeing, right? But consider we cannot directly pass a data to the machine, right? So I hope you all guys have know already, like what a machine can understand, whether a machine can understand a words, strings, boolean, like those things. No, machines can understand only zeros and ones. So similarly in data science, the machine learning AI model, ML model, DL model, everything can learn only the numerical value. So you need to convert all the data to a numerical value, not that. You need to convert in a manner that the model can be digestible. So here we are having a technique called as data pre-processing, which involves lots of things when coming to the data set in a text or and a number format. It includes duplicate removal, insertion of new column, deletion of existing column, unnecessary values removal, null values installation, imputation, like those things. Whereas when it comes to image, we are having data augmentation, grayscale image, colored image, then feature extraction from image, like those things, guys. So the thing is, whenever you are going for data pre-processing, it's like a, what to say, data collection is a prime thing, where it on top of this, if we do a proper data pre-processing, then everything is like cake for us. Okay, so everything we can do in a very very simple format, guys. So that is what the data pre-processing, which is very very important in the data collection process, like data science process. Yes sir, over to you.
Yeah, guys, again, only come to this session if you have watched 5 to 10 times the earlier sessions, so that it will be helping you. You will have understanding, and you have to do reinforcement learning, absorb, and then digest the information and then apply. So if you have not subscribed our channels, kindly subscribe. So this is going to be a year-long program, so continuously learn. So data pre-processing, it's a foundation for the success because uh, it's very crucial for data science projects. It ensures the data cleaning, consistency, ready to be used by machine learning algorithm. So if it is not clean, consistent, then the algorithm will learn only what you're giving, garbage in, garbage out. So you have to clean it. It should be consistent so that the algorithm will learn properly. Otherwise, you will not have success. You will not have outcome what you're desiring. So without effective pre-processing, the accuracy and reliability of the model can be compromised, which I already mentioned. So keeping it simple, that you have to learn data cleaning, consistency. Data needs to have consistency so that the outcome is as desired, what you want, and whatever you're not compromising the objective function of the project. So that is why it is very, very important to do data pre-processing. Okay, so consider this, and we'll move to the next slide.
Yeah, next up, I think I have discussed this, right? Data cleaning, that is handling missing values. So missing values are a common problem in the real world data set, right? So whenever we are just creating a 10,000 or 10 lakh plus data in a real world, there could be some kind of values which will be missing. So as a person itself, whenever you just log into any website, you will just enter either a mail ID password or a phone number or a password. Then there is a problem of missing any one field. So it's a very obvious and it's a real world scenario where we need to handle the missing values in some way. Okay. First is imputation. What imputation means? Like you replace the missing value with the estimated value based on their data points. Okay. So we are just inputting what can be there. Okay. Next, deletion. Removing rows or columns with missing values, but only if the missing values doesn't significantly affect the impact of the analysis. That is, you can delete the missing values, the rows that contain missing values, only if it doesn't affect event incentive insights. The thing is, if you are having only 10 records, you should not remove a single record because it is having a single null value. If you are having lakhs and lakhs of data and there is only one data which is lagging in the that has a single null value, then don't worry about it, just drop it. Okay. So this is what the statement is saying. And then model selection. So use algorithm specifically designed to handle missing data such as k nearest neighbor or decision tree, and we are having one more thing called as db scan. So don't worry about the technical sum. So these are the things that is very helpful in finding the outliers. Okay. And yeah, okay, so and also it is you able to find the missing values also. So this is what about cleaning the missing values. Okay. Yes, sir, over to you.
Yeah. So again, data cleaning has these features which we'll say you have to understand. In data cleaning, what you have to do is you have to replace missing values with estimated value based on other data points. This is very critical. That's called imputation. So you have to do, you have to impute, okay, replacing the missing value with estimated value based on other data points. You have to give some, you have to replace that, okay, and then deletion, removing rows or columns, okay, with the missing value. Whether, see, your data will be in two forms, rows and columns, right? So you have to check missing value, but only if the missing data doesn't significantly impact the analysis. You have to see that. If it is impacting, then and only. If it is not, then you should not, because it should be, you should see that aspect. So you have to remove rows and columns with missing value, but only if missing data doesn't significantly impact the analysis. So then and only if it is impacting your analysis, then don't remove those missing values. That's what this statement is. Then algorithm selection. Using algorithms significantly, you design to handle missing data. Okay, using, you have to use the algorithms which will help whatever missing data is there, handling that, such as k nearest neighbor and decision trees are the best algorithms for finding missing values. Okay, so this is how we can go to the other slide. Thank you.
Yeah, sure, sir. So what will be the next slide? Let's see. Yeah, feature engineering, guys. I love this thing because we're gonna create some new feature, okay, based on the existing feature. That's it. Okay. So that is what called as feature engineering, which will be very helpful when you are building a model, because model relies on multiple features, right? When we need to club multiple features and create a new feature, then it becomes feature engineering. Okay. Whatever you do in order to increase a result or anything that comes under the model's performance, it comes to feature engineering. Okay. So first thing is feature extraction. Derive new features from existing ones, such as creating a total incomes feature from the sales and bonus features. So based on these two features, that is sales and bonus, we are just deriving a new feature called as bonus income. Okay, that is total income. Next, feature transformation. Applying mathematical transformation to the existing feature, such as converting a categorical value to the numerical value. So it's simple, right? Feature transformation means, let us consider in a target value we are having two different like fruits. Okay, we have one is apple, another one is orange. So in order to just transform those things, since they are in a categorical feature, we are just transforming it to a new numeric feature. That is, if apple comes, it is 0, and then orange comes, it is 1. Like that we will do. And finally, we are having feature input interaction, creating a feature by combining existing features such as creating a ages into income feature to compute the interaction between age and income. Okay, so yeah, these are the things that we are having in feature engineering. Yes, sir. Over to you.
Yeah, so feature engineering is creating new features, guys, with existing data. Okay, so first point number one is driving new features from the existing ones. Simply, so A plus B, suppose you have A plus B, so there would be you will have, it will be equal to 2AB, right? Kind of thing. So you can have another feature combining that. Suppose you've combined, okay, let me give you example. We have three colors, so red, blue, and green. So these three colors can form other all the colors, right? So when we combine them with different colors, like we combine green with blue, we'll have a different feature. We'll combine red with the green, we'll have different. Similarly, here, driving new features from the existing ones, such as creating total income feature from salary, okay, and bonus feature. So this is how we can create a new feature from the feature. Like you can have a sub data from the data. So new feature, okay. Then feature transformation, applying mathematical transformations. You transform from existing features, such as converting a categorical feature into a numerical feature. So this is how you can transform feature, okay. And then we have feature interaction, which is creating new features by combining existing features, such as creating a age income feature to capture the interaction between the age and income. So we need to, here we'll see interaction between features, and then we can create a feature out of it. So this is how you can create features and new features from the existing data. That's called feature engineering. Let's move to the next slide.
Yeah, you're right, sir. Okay. So next we are having handling data. So categorical data handling. So categorical data or the group into categories such as gender, color, location. These features need to be converted to a format that machine learning algorithm can understand. Common techniques includes one-hot encoding, label encoding, and ordinal encoding. Guess one thing. As I mentioning previously, computer does not know, or it is a dump. Actually, as Sadis mentioned, it is dump unless and until we are feeding something. So we need to feed computer in a manner that they can understand, and also this one more person can understand who is building that. Okay, the thing is, you need to convert all the categorical value to the numerical value. Then only they will be affordable and they will be ready to work that. Okay, you need to make the things very simple. You are just putting categorical data handling. Okay, but this is not a case today. Like we are just seeing data processing, right? So what is a categorical data handling? Whenever we are having a string value in the column, we need to convert it to an integer value. How we can convert mean one hot encoding, label encoding, or ordinal encoding. One hot encoding means what happens means it is a binary feature for each feature where one indicates the presence of the category and zero indicates the negative, like indicates absence. Okay, whenever you are having encoding, okay, you just need to consider creating a binary feature where the first feature, which is burn, okay, that is considered as the presence of category. Zero means it's an absence of category. Whereas we are having something called as label encoding, where it will give the unique values number range starts from like 0 or 1, I don't know, and it will ends up how many categories you are in. Next, ordinal encoding is similar to label encoding, but accessing numeric factors or values based on the order and the suggestion. So this is also a great thing, guys. So it is a like similar to label encoding. Okay, but assigning number values based on the order of the categories. So this is a combination of both one-hot encoding and label encoding, which is equal to ordinal encoding. Yes, sir. Over to you.
Yeah, again, we have to do categorical data handling. So, in categorical data handling, we represent data that can be grouped into categories, such as gender, color, and location. So, these are three different categories. Example, okay? These features need to be converted into format that machine learning algorithm can understand. Common techniques including one hot coding, we have to do label encoding and ordinal encoding. So what we do is we code these features. Okay, we the encoding means coding. We code with binary features 1 and 0. 1 indicates the presence of category, 0 indicates the absence. And then in label encoding, what we do is assigning a unique numerical label to each category, which preserves the order of the category. So that's the label. You just label. Here, one hot encoding means you do binary coding. One means present, zero means no, not present. Okay. And then in label encoding, what you do is you give a label to encoding, which you have done. So that's different. Okay. Then we have to the category. Okay. So you have a label to the category so that you can identify. So here you do one hot encoding where you do the positive and absence and presence. But in label encoding, you give categorical label to put that category. You have to give label. Okay. Then in ordinal encoding, similar to label encoding, but assigning numerical value based on order of the category. Here, you have to focus here on the specific words, guys. So ordinal encoding, if label encoding was sufficient, why we have ordinal encoding? So you can ask this question. So the feature of ordinal encoding is to give assign numerical value based on order. That is why it is ordinal. So order of the category, you need to have these three things clearly. One hot encoding means you assign to the category 1 indicates presence, 0 indicates absence. In label encoding, you label to the category. Okay. And in ordinal encoding, you give label to the order of the category. These are three things. It might be confusing, guys, but you have to understand deeply that there's very thin line between these encodings, and they are completely different. With small thin line, they are very different.
Yeah, that's actually great, sir. Yeah, guys, like this session, like till now, what we have done means we go for a data pre-processing, right? So if you guys can, we just go back and summarize everything. So data pre-processing, it is like a major thing, major part in building a data science application where we need to pre-process data, then only we can work on it. And then we are having how to handle this missing value. So we have discussed different techniques like imputation, detection, algorithm selection. Then we are having feature engineering where it is a very interesting topic because we're gonna build a new feature which is not gonna exist. So that's a great thing. Him Vignesh, keep it up the great work. And yeah, so thing is, so we are having feature engineering. Okay, so we are just creating new features, right? So whenever we are creating a new feature, it is like a very interesting thing. You need to create a new feature based on the uh, whatever the features that are existing. Okay, so it is very interesting thing. Based on this, you can do multiple things, guys. Okay, so the next thing that we are having here is, we have seen about categorical data handling, right? So whenever you are having string kind of variables, you are not able to understand. Okay, as a human we can understand, but as a machine it cannot understand, right? So you need to just specify, this is string value that you need to convert to a numerical value. For that we are having different ways, so like one not encoding, and then label encoding, and then we are having ordinal encoding. So yeah guys, these are the pre-processing steps that we have seen for this session. Hope you have enjoyed this session, and thank you so much. We will meet in the next session. Yes, yeah guys, bye.
Yeah, bye bye, guys. Go and watch all these sessions 5 to 10 times and understand each and every element. And write in the comment section your feedback, and also complete all the assignments. And once you do go through all the previous sessions, then and only come to this session and subscribe to our channels and write in the comment section your feedback so that we can always improve. Thank you.